Welcome back to the GMP and Quality Fundamentals series, and this is Lecture 16. Over the past 3 lectures, we have covered risk-based thinking, method validation, and method lifecycle management. All of those topics help you build and maintain a high-quality system. But today we ask a different question. How do you know if your quality system is actually working? The answer is quality KPIs and metrics. If you cannot measure it, you cannot manage it. And in this lecture you will learn exactly what to measure, how to measure it, and what to do with the results. Let us get started. Here is what we will cover today. Number 1, you will understand what KPIs are, why they are required in GMP, and what they are actually for. Number 2, you will learn the most important laboratory and QA metrics used in GMP environments. Number 3, you will understand the difference between lagging and leading indicators. This is one of the most important distinctions in performance measurement. Number 4, you will see how KPIs connect to management review and what regulators expect to see. And number 5, you will get a practical 5-step framework for building your own KPI system. Let us start with the most important question. Why measure at all? Imagine a pilot flying a commercial aircraft with no instruments. No altimeter. No fuel gauge. No speed indicator. No compass. They can feel the plane is flying. The engines sound fine. But they have absolutely no idea if they are on course, if they are running out of fuel, or if they are about to stall. They are flying blind. A quality system without metrics is exactly the same thing. You can feel like things are running well. The lab is busy. Products are being released. But without measurement, you have no idea whether performance is improving or declining, whether a failure is about to happen, or whether your resources are going to the right places. Now, this is not just a best practice. It is a regulatory requirement. The FDA 21 CFR Part 211 and EU GMP guidelines require that management reviews quality data at defined intervals. ICH Q10, the international guideline for pharmaceutical quality systems, specifically calls for performance indicators as a core element of a quality system. Beyond compliance, KPIs serve 3 critical functions. They act as an early warning system, detecting problems before they become OS results or recalls. They enable continuous improvement by showing you exactly where the system is underperforming. And they give management the information needed to make decisions about resources, priorities, and risk. Before we look at specific metrics, I want to make sure you understand a fundamental concept in performance measurement. The difference between lagging and leading indicators. Lagging indicators measure what has already happened. They are outcomes. The number of OS results last month. The number of deviations raised this quarter. The number of customer complaints received. The number of product recalls. These metrics are important because they tell you the actual performance of the system. But they have one major limitation. By the time you see a problem in a lagging indicator, the damage is already done. The OS already happened. The complaint already came in, leading indicators. On the other hand, measure inputs and activities that predict future outcomes. Training completion rates. Equipment calibration compliance. SOP review rates. CAPA effectiveness verification rates. The number of near-miss events being reported. Here is the key insight. If training completion is falling behind, the probability of analyst errors increases. If calibration compliance is slipping, OS results from equipment issues become more likely. Leading indicators give you the chance to intervene before the problem occurs. A strong quality system tracks both types. Lagging metrics tell you what went wrong so you can investigate and fix it. Leading metrics help you prevent the next problem before it happens. Most quality systems are heavy on lagging indicators and light on leading ones. Work to balance this. Now let us look at the specific metrics. We will split them into 2 categories. Laboratory quality metrics and QA system metrics. Starting with the laboratory. The 4 core laboratory KPIs you should track in every GMP lab. The first is the OS rate. This is the percentage of all tests performed that produce an out-of-specification result. The formula is simply the number of OS results divided by total tests performed, multiplied by 100. Industry benchmark for routine release testing is typically below 0.5%. Tracking this metric over time is more powerful than looking at a single month. If your OS rate is stable at 0.3%, that is normal for your system. If it suddenly jumps to 1.2% in 1 month, that is a signal. Investigate by method, by product, by analyst, and by instrument to find where the problem is concentrated. The second is right first time rate, or RFT. This measures how often a test passes on the very first attempt, without any repeat or retest or invalidation. The formula is tests passed on first attempt divided by total tests, multiplied by 100. Target is typically above 95%. A low right first time rate is expensive. Every retest consumes analyst time, equipment time, and materials. It delays batch release. And it signals something is wrong. Track RFT by method and by analyst. An analyst with an RFT of 85% when the lab average is 96% needs targeted investigation and support. The third is laboratory turnaround time. This measures how long it takes from receiving a sample to delivering a GMP-approved result. Target depends entirely on the test type. Routine release testing might target 24 to 48 hours. Stability samples might allow 5 to 10 business days. Chronic delays in turnaround time indicate capacity problems, training gaps, or equipment reliability issues. They directly impact batch release timelines, which creates pressure on manufacturing and can affect product supply. The fourth is the test invalidation rate. This tracks how often a test run is declared invalid. Each invalidation is a cost. And there is a critical data integrity point here. You cannot invalidate a result simply because it is OS. An invalidation requires a documented scientific justification that proves the test was invalid for a laboratory reason, not a product reason. Inspectors look very carefully at invalidation decisions. Now the QA system metrics, the 4 core QA system KPIs. First, CAPA on-time closure rate. This tracks what percentage of CAPAs are closed by their committed due date. Target is typically above 90%. CAPAs that remain open past their due date represent unresolved quality risks. They also represent a broken promise to your quality system. If you committed to closing a CAPA by a certain date and did not, why not? What got in the way? FDA and EMA inspectors review CAPA overdue rates during inspections. A list of 10 CAPAs that are all overdue by months is a significant finding. It signals that the quality system is not functioning, regardless of how well written the CAPAs are. Second, deviation rate per month or per batch. Track total deviations and repeat deviations separately. Total deviation rate tells you about process stability. But repeat deviation rate is the more critical metric. If the same deviation is happening again and again, your CAPA did not work. The regulatory question will be, why are you raising a CAPA that does not fix the problem? Third, audit finding closure rate. Every internal audit finding has a committed response timeline. This metric tracks whether those responses are delivered on time. Critical findings should close within 30 days. Major findings within 60 days. Minor within 90 days. These timelines should be defined in your audit procedure SOP. Inspectors use this metric to assess whether you act on your own audit results. If you find problems in your own audits but never close them, that tells the regulator that your quality system is not self-correcting. Fourth, change control cycle time. This measures the average number of days from when a change request is submitted to when it receives final approval. If your change control process takes 4 months for a minor instrument software update, that is a problem. It signals bureaucratic inefficiency that slows down legitimate quality improvements. Benchmark. Minor changes should close in under 30 days. Major changes involving validation work in under 90 days. Track this by change type and by department to find the bottlenecks. Let me show you what all of this looks like in practice. This is an example of a monthly quality dashboard. Looking at this table, you can read the health of a quality system at a glance. OS rate is 0.3% against a target of 0.5%. Green status. And the trend is improving. This is a healthy metric. Right first time is 96.2% against a target of 95%. Green. Stable. Lab turnaround time is 38 hours against a 48-hour target. Green. But the trend shows it is creeping upward. That upward arrow means watch this carefully. It is still in target, but it is moving in the wrong direction. Test invalidation rate is 1.8% against a target of less than 1%. Red status. This needs immediate investigation. Something is causing an unusually high number of invalid runs. CAPA on-time closure is 87% against a target of 90%. Amber. Not red, but below target. Action is needed. Assign the owner to review all overdue CAPAs this week and get commitments on closure. Change control turnaround time is 52 days against a target of 30 days. Red. The process is too slow. This needs a process review. This dashboard is a one-page summary that tells management exactly where to focus attention this month. Green metrics get acknowledged. Amber and red metrics get owners assigned and action plans documented. The decisions made in this review meeting must be formally recorded. Now let us connect KPIs to the broader regulatory framework. ICH Q10 requires that senior management reviews quality performance indicators at defined intervals. This is not optional. It is part of the Pharmaceutical Quality System Standard. And the FDA and EMA both reference ICH Q10 in their inspection guidelines. What this means in practice is that your quality metrics must be presented to senior management, typically at a monthly meeting, at a quarterly review, and as part of the annual product quality review. At the monthly level, the focus is operational. OS rate, deviations, CAPA overdue list. What are the immediate issues that need management attention and resources? At the quarterly level, the focus is trend analysis. Are metrics improving over time? Are there patterns that point to a systemic issue? Are any departments consistently underperforming? At the annual level, it is a full quality system review. How did every metric perform over the full year against target? What were the significant quality events? What regulatory outcomes were there? What are the improvement priorities for next year? All of these review outputs must be formally documented. Minutes of the management review meeting, including the decisions made and the owners assigned to actions. Inspectors asked to see these records. If the records do not exist, the review did not happen in a regulatory sense. And that is a finding. Let me give you a practical 5-step framework for building a KPI system that actually works. Step 1. Define what you need to measure. Do not start by copying someone else's KPI list. Start with your biggest quality risks. What failures have cost you the most in the past? What does your regulator focus on when they visit? What does your QA manager worry about most? Those risks should drive your initial KPI selection. Step 2. Set targets before you start measuring. A number without a target is just data. It is not a metric. Set your targets based on industry benchmarks, regulatory expectations, or your own historical performance as a baseline. And document the rationale for each target. Why is 95% right first time the right target for your lab? The answer to that question should be written down. Step 3. Assign ownership. Every single KPI must have a named person who is responsible for collecting the data, calculating the result, reporting it at the management review, and investigating when the target is missed. KPIs with no owner are ignored. And ignored KPIs do not improve. Step 4. Review regularly and formally. Build quality metrics into your monthly management meeting agenda as a standing item. Not an optional agenda point. Not something you look at when there is time. A fixed, formal agenda item. The review decisions and action assignments must be documented in the meeting minutes. Step 5. Connect every missed target to an action. When a metric misses its target, the response must be documented. What is the root cause? What is the corrective action? Who owns it? What is the deadline? KPIs only drive improvement when they are connected to consequences. Without that connection, you are just collecting data. Let us bring it all together. 6 things to remember from this lecture. Number 1. KPIs are a regulatory requirement in GMP. ICH Q10 requires management review of quality performance indicators. This is not a best practice. It is mandatory. Number 2. Lagging indicators measure outcomes after the fact. Leading indicators predict future performance. Track both. Most labs track too many lagging and too few leading metrics. Number 3. The 4 core lab KPIs are OS rate, right first time rate, turnaround time, and test invalidation rate. Know the formula and the target for each one. Number 4. The 4 core QA system KPIs are CAPA on-time closure, deviation rate including repeat deviations, audit finding closure rate, and change control cycle time. Number 5. Every KPI needs a predefined target, a named owner, and a documented response when the target is missed. Without these 3 elements, a metric has no value. Number 6. Management review records are regulatory documents. FDA and EMA inspectors ask for them. If the review is not documented, it did not happen. That is Lecture 16 complete. Coming next in Lecture 17, we do a deep dive into internal audits. How do you plan one? How do you run the opening meeting? What does a good audit trail look like? How do you write audit findings? And how do you close them? Everything from planning to the final report. If this lecture was useful, please give it a like. Subscribe if you have not already. And drop your questions in the comments below. I reply to everyone. I will see you in Lecture 17.